Hi everyone, today we'll be talking about another lead code problem which is trapping rainwater. So given a non-negative integers representing an elevation map where the width of each bar is 1, compute how much water it can trap after raining. So you've been given an example where this is the height and width of every bar is 1. So the first one is 0, the next one is 1, the next one again is 0 and 2 and so on. So you have to find that how much rainwater it can trap. Like here it will trap one one unit of rainwater. Here it's trapping 4 units of rainwater, and again here 1 unit of rainwater. So total output that you have to return is 6 units of rainwater. So let's quickly look at the intuition behind solving this problem, and then we'll come to the coding part. Okay. So I've already done the same example over here, but before we start looking at this example, let's try to understand, how will we solve this problem. So what we need to understand is that if you have a bucket in which you can fill the water, basically it's going to fill the water till the top of here. If you try to fill any more water in it, it's going to spill over. So let's take another example. Now at this time let's keep the height of the two left and right different. Now the maximum water that it can fill is to the minimum height of both left and right, and anything more than that will essentially spill over. So this is the logic that we need to apply. We need to find the minimum height for both the left side and the right side of a bucket, and whatever water is filled inside it is going to be the unit that we need to count. We also need to understand one more thing. Now let's say if it's an irregular bucket, okay, it's like this shape, and now if I fill water in this, even though it's going to fill water till this height, which is going to be the minimum height of left and right, but there are some shapes within it, right? So we need to basically take out um, one element from here and one element of here from this entire unit volume of the bucket before we can say that how much water is filled in this bucket. I hope these three examples are clear. Now let's look at how we can solve this problem. So essentially, first what we need to find is the maximum height that is of the left side that can hold water. Similarly, what is the maximum height of the right side? And then we need to calculate if there are anything inside the bucket which we need to subtract. So these are the essentially three steps that we are going to do to solve this problem. Now first let's try and compute the maximum height for the left side of the bucket. So we are going to take a variable left, which initially for which it's going to be an array. I'm going to assign the value 0, and I'm also going to keep another array which is going to be left array, which is going to store at every point for all these points what is the maximum height that the bucket can hold water. Now let's start at this level. First let's compare 0 to 0. Can we hold any water if there is no height? No. So the answer for the first one will be 0. For the next step, let's see. Now 1, yes, there is now some height that has been gained up. So let's keep that as 1 and scratch it out and maintain that as the maximum one. Now for 0, again we can have a left bucket which can have the value of 1 over here. So we are going to keep that as 1, and this continues to be 1. Now we have come to 2. Now our pointer is here. So I'm going to scratch this out, make this 2, and I'm going to make this 2 now. Now let's move to this point. Now it's 1, so 2 is greater than 1, so left continues to be 2. So for all these points, it's now move on to this point. Again, 2 is greater than 0, so it's going to be 2. Now moving on to this point, 2 is greater than 1, so again I'll store it as 2. Now we are coming to another big point, which is 3. So now my next point will be 3, and I'm going to cross this out to store 3. Now coming on to this point, it is 3. So for all these remaining points going forward, it will continue to be 3 as the maximum height. So I'm just going to store 3 for all of them. Now let's do a very similar exercise for the right side. Now right, I'll start from here. I'm again going to keep that as 0 and I'll have another right array just like left array to store all the maximum height for the bucket. So this is 0. This will also be 0. For next, it is 1. So this 1 is greater than 0. So 0 will cross out and I will write 1 over here. For next point, it is 2. 2 is greater than 1. So I'm going to store 2 over here. For next point, it is 1. So 2 is greater than 1. I'm going to continue to keep it as 2. It is again 2. So 2 is basically it's equal. So I'm continuing to write it as 2. For next point, it is 3. So 3 is greater than 2. I'm going to cross this out and now I'm going to start storing 3 as the maximum height. And for all the remaining points, I see 3 is the maximum one. So 3 continues to be my maximum height. Okay, now I need to reverse this to basically, I know that from this point, the maximum, if you look at this area, right? Let me change the color. So if I look at this area, basically from here, I can technically right height can be this much long, right? For all these points. But I also have to look at the left side. So from left side here, this much is the water that it can store. So 1 unit of water. Now let's coming at 2. So this much is the water that it can store. So this basically becomes the highest height. For if I need to know the highest height for this point, I need to um, basically switch this from left to right. So basically my right array, my new right array becomes 3, 3, 3, 3, 3, 3, 3, and then 2, 2, 2, 1 and 0. So now I've got these two. Now I also need to see that, if anything is of this manner. So basically, if I have any blockers, like I have a blocker here, this is a blocker here. So no water is basically getting stored, correct? Over here in this area. So this is also something that I need to minus. Now how will I get that? That is just taking the height of each of these arrays. So this is something that I need to store in another array. So now I need to calculate minimum height. So minimum height, why do I need to calculate? Because if you remember the example of the bucket can only store the water based on whatever is the minimum height of both left side and the right side. So this is my right array, this is my left array. I will just calculate the minimum of these two. So my first value will be minimum of 0 and 3 is 0, then it's 1, then 1, then it's 2, 2, 2, 2. After that, now it flips over here. Minimum is 2, 2, 2, 1 and 0. And now I need to basically subtract these elements as well, as I explained. So I need to subtract the height of each of these to get to the water that is stored, right? Because right now what it is doing is it's calculating, say for this area, it's calculating that 2 units of water is stored here, because it's not right now minusing the height of this. If it minuses the height, then we know that no water is being stored over here. So if we minus this array from this, our final array will be 0, 1. So if you see, 1 water is being stored here, right? Because the height is 0. Sorry, it's 0, 0 and then 1. Now for 2, it's again 0, then it's 1, then it's 2, then 1, then 0 and 0 and so forth. Now in the end, if I add all of this array, I get 1 plus 1 plus 2 plus 1. So which is equal to 6, which is the answer that we are looking for. I hope this logic is clear. If you have any questions, please write down in the comment section and I will be able to answer those for you. Now let's quickly just look at the coding of this problem. So as mentioned, let's keep a left array which is going to be blank. Let's initialize right array which is also going to be blank for now. And then this will store the final result which is going to be blank. And we are going to have a pointer left which is going to be 0 and a right pointer which is going to start from 0. Now for every element in height, if x is greater than left, then left is replaced by x. And we are going to write that value of left in the left array. Let's repeat this process for right side also. Only thing is, for this we need to basically grow from the last element. And as I mentioned earlier, we have to reverse the right array. Now we have to calculate the minimum height that is there. So we just have to store the minimum height from the left array or the right array. So if left height is minimum, I'm going to append that, else I'm going to append the right array. Now I'll calculate the final um, rain that is being collected by minusing the minimum height with the actual height that is there. That is just to remove these blocks. Like, remember, if there is this block, then there will be no rainwater stored over there. So just to remove that, we are going to subtract the minimum height with the height array. And in the end, we just have to return the sum of the rain array. That will give us the final results. Let's run this code. Let's submit the code. I hope you enjoyed watching the solution. If this was helpful, please subscribe to my channel. Thank you.